Here we go, though. Closure. Here it is, folk. Feel free, people, to throw in your questions as we go. Don't get answering questions of each other's too much in the chat, because normally the answer is just coming up. These workshops have been given 100 times, and so they tend to give the answers at some point. By design, you're not going to get them immediately. Okay, so here we go. Closure. I think, people, the most esoteric, the most obscure concept in JavaScript, the one that when I gave this talk at a lunchtime talk to the New York Times engineering team, half of them, the senior developers in JavaScript, did not get, not as closure, but the thing that it depends on, which I'm going to tell you, is how do we return a function from another function? And they didn't get it. They didn't know it. By the end they did, but they didn't when they came in. And that should give you great confidence that even if you find tonight hard, you're in the leagues of some of the hardest engineering in JavaScript. We're going to try and make sense of it. Professional level functions. We're going to see that if you get closure, you get some of the most interviewed on questions like, hey, build me once, build me memoization, which is one of the most popular interview questions at Google for the JavaScript engineering teams. Of course, we also interview on it for Codesmith because we want you to come in at that high level when you get into Codesmith. But it's also a day-to-day, really useful set of functions. Memoization is a core technique in programming that you ask most developers, they're using it if they're following best practices at least once a week, maybe once a day as developers. The module pattern. I'm working on my hard parts Node.js, which currently is a blank sheet of paper and a series of slides that I did when I was making you all on Monday listen to my Node talk. I've got a piece on the module design of Node. And what do you know? It all rests on tonight's concept. I couldn't believe it. I knew module pattern rests on it. I didn't realize, I guess, that Node's modularity, if any of you ever worked with Node.js, you know how you pull in stuff, you require stuff in, that it all rests on tonight's concept. This is the dominant concept in JavaScript. If we get it, we become very powerful JavaScript developers. In fact, there's a guy who's not on tonight called Youssef, I think, who comes to Hard Parts, came to a lot last year, came to how to get hired, never went to Codesmith, never even applied, whatever, just told me yesterday he got a mid-level job, only a bit below the Codesmith average, by just attending the free talks. And he said the closure one was the one that gave him the edge. That's not me, whatever, who cares? I'm pretty disappointed he didn't apply to Codesmith. I'm just happy that this is the stuff that you need to know for your job interviews. All right, let's move on. I'm not going to show the underlying principles of JavaScript here tonight. We're going to get it as we go, because many of you, I think, have been to Hard Parts before. All I will say is let's take a quick look at this code here. Yeah, I'm not going to diagram this piece out, but what I will say is as we run this code, so you're going to store num is 3, store multiply by 2 as a function, call multiply by 2 with the input of num, which is 3, so run multiply by 2 with the input of 3, and then later run multiply by 2 with the input of 10. I'm not going to walk through this code line by line for once, because I think most people have seen this before. We're going to walk through JavaScript code on the next slide, don't worry, but this is the absolute fundamentals. But I want to call one thing to your attention. Notice that when I run multiply by 2, oops, I dropped my pen. When I run multiply by 2 with the input of num, which is 3, the output stored in 6 presumably would be, an output would be 6. The output of running it with 10 would be 20 stored in new output. Note that there is no connection between those two functions being run. When I run multiply by 2 the first time with the input of 3, and then I run it again with the input of 10, the input of 3 is absolutely forgotten the next time I run the function. We're going to see in a moment that means that when that function is run, inside of it we get a little store of data. Well, the 3 is stored inside of multiply by 2, the 10 is stored inside the running multiply by 2. When they do that, there's no connection. We do not remember the 3. No. We do not remember the 3 when we then run multiply by 2 again. We wouldn't want to. We're running it first with 3, get the output 6, and move on. We run it with 10, get the output 20, move on. We do not remember anything inside our functions between their runnings. If I run multiply by 2 with the input of 3, no memory of the input of 3 or the output of 6. Next time I run it with 10, brand new data. That's all I'm going to hold for now. We're going to see more of that. I'm not going to diagram that out. We're going to discover, well, here it says here, when our functions get run, normally, we create a live store of data. Inside of them, we'll see that in a second, don't worry. It's known as a local memory. Well, we'll see some of these fancy names soon, for that function running. When the function finishes running, it's local data. That means the data that's stored just for running the function. So if I run multiply by 2 with the input of 3, 3 is stored inside a multiply by 2 before I multiply it by 2 and return out 6. That data, when the function finishes running, the 3 is deleted. The only thing that's held on to is the returned out 6. Input of 3, return out 6. The 6 gets held on to only because it gets returned out and stored outside in output. Here's the most powerful thing we could do in JavaScript. It would change everything about how we run and write code. And that would be if we could imagine functions that, yes, when they finish running, delete all the stuff inside of them besides what gets returned out. We don't want to keep the 3 because next time I run multiply by 2, I don't care that I ran it with 3 before. Now I want to run it with 10. I don't care if I ran it with 3 before. Who cares? I don't want to hold on to that because I got the 6 out of it. I'm done. I'm now going to run it with 10. But there are a ton of times where if I were to be able to hold on to some data in between the running of my functions, so I could run multiply by 2 with the input of 3, return out 6, then run it again with the input of 10, return out 20, but hold on to some data, some information, some stored values, as they say, in between the runnings, it would change everything about how I wrote my code. My applications would be transformed. And that's what we're going to do. But what does it say here? But what if our functions could hold on to live data? They call it state, the live data stored in our function, between their runnings. Between. What is this emoji? Oh my God. This would let our functions have a persistent, I'm going to give it a different name actually. You know what? I'm going to call it a permanent memory, a permanent store of data attached to them. So when I run multiply by 2 many times, it would have new data, but also permanent data attached to it. And folk, this would change how we write code. For example, we might be able to limit our function to only run once. First time we run it, we hold on to a value saying, you've already run me, and we save that. And the next time we run the function, we check that, and now we are not allowed to run the function again because the function remembers stuff from the previous time it was run. It would remember things from previous times it was run. It'd be like in Westworld, where I watched Westworld season 2. It wasn't very good. I gave up. But it would be like in Westworld. They're meant to reset. Functions are meant to be reset. Westworld characters are meant to be stateless. They're meant to not persist data. Michael, why have you unmuted yourself as though you're going to provide some fan?
No, I have a question. I gave up on Westworld too during season 2.
Yeah.
I had a question. When you say it's deleting or it's losing the state, is it just dropping the reference and picking up a new reference, or is it literally removing it from memory?
It's literally automatically deleting.
So it's garbage collecting.
They call it garbage collecting.
Okay.
It's automatically deleting all the data inside the function.
Okay.
Michael, I've chosen not to diagram this at this point, but you'll see it in a second. We're going to see it in this next block here. Because it all starts, folk, with us running a function, and rather than returning a number, rather than it outputting an array, rather than outputting an object, outputting another function. Let's see it in action. Here it is. Functions can be returned from other functions in JavaScript. There's two parts. Well, we're going to see it. Let's just diagram this out. So we've got this pretty function here, create function. We're going to save it. There it is, saved. We're then actually going to give it a second label. I'm going to show you why in a second. Then we're going to run create function. And whatever comes out of it's going to be stored in generated func. We're then going to add parens to the end of generated func. What the hell's going on here? Huh. Do not fear. Let's start diagramming it out, people. I want to see this diagrammed out line by line. Let me know anybody who can't see this code in the left-hand corner. It's very important. Otherwise, I'll just take a screenshot of this while it's showing for yourselves. Okay. Hopefully you can see that left-hand side there. All right, folks, here we go. So some regulars, I'm going to start off with all of you because you know how to talk through this code. And new friends, try and pick up how we're talking through the code. We're just going to talk through it as JavaScript runs it. JavaScript does two things when it runs code. It goes through the code, does whatever it says to do, line by line. Hello, Sam, nice to see you. And it stores stuff in memory. That means it stores data as it goes. For example, in this first line, we're storing a function. We're storing it in memory. It's not being, whenever you see the reference to create function later on, do not think that JavaScript's going back up the page to find it. No, we're literally going to grab this whole function's code and store it over here in memory to be used later on as JavaScript when we write code to use it. So here we go. But starting off with line 1, Dwayne, as a regular, my friend, what are we doing there in the very first line of code? There it is.
We are declaring a function called createFunction.
Excellent. And in terms of my memory, Dwayne, what's that doing?
That is going to create a function level execution context.
Now, we only create execution context when we execute.
Oh, yes. I'm sorry. You're right. You are creating that in global memory.
Aha. We're storing it. We're just storing its code. I might even, you know what? I might even show, just for a second, I think it might be useful to show. Look at this. I'm literally taking that function's code. Oh, look how small it will go. That's nice. Oh, hooray. Didn't need to do that. And I'm storing it there. Yes. Memory, under the label create function. Look at that. That's what I just did in line 1. That's what JavaScript just did. People, the first time I realized that, oh, I had no idea. I thought the functions were just kind of sitting there in our text that we wrote. No. When JavaScript sees the keyword function, it goes, what's this mean? It says, store this function code for later. That's really important. And by the way, when we store a function, it has two parts. It has its name, and then, totally separate, it has its stored code. That's going to be really important. That might mean, by the way, we could have potentially multiple labels, multiple names for the same function code. Well, let's see. Next line, Nathan, what's our next line of code? Line 1 was storing the whole create function definition in memory, which is just a posh word for our store of data and functions. Nathan, what's our next line of code? It's a pretty hard one.
We're going to create a constant called second label in global memory, and it'll be assigned the function definition of create function.
Oh, what incredible, incredible precise technical communication, people. I hope we can appreciate how precise that was. It will be assigned the function definition, not the label. That's the label. That's the function definition. When you declare a function, store this function code for later. I should have said store its label and store its definition. Those are two different things, meaning we can give it a second label, which is exactly what we did here. And note, people, we did not go inside of create function because we did not run create function. We just saved it. So second label is now, we've now got one label for create function, and we have a second label for the code of create function. Meaning, if I wanted to run create function's definition, its code, I could actually run it by doing this. Second label, and it would actually go and look, second label, and it would run the code of the function formerly known as create function, or additionally known as create function. We have two labels for the same function code. So we saved the function and its label in one go in the first block, and then we saved a new label for the same function code in the second line of code. Okay, folks, I'm only showing you the second label. We're not going to use that function by its label, the second label. We're not going to use it by that label. I just want to show you that you can have, I want to make it clear there's two parts to a function being stored. Its label and its definition, its code. Meaning, well, we'll see. We'll see. Okay, excellent. Thank you to Nathan. Let's have David. Well, actually, let's have YC. YC, can you help me out with the third line of code? If you just start me off, YC, with the left-hand side there. Just the left-hand side. What's the left-hand side saying to do there, YC? Command Shift A, YC. Excellent.
So we create another variable, GeneratedFunk, to
Hold that 1 second,
call the
YC.
function.
Yeah, it looks good. Sounds good. Sounds close. GeneratedFunk is, they don't call them variables. I understand how we call labels variables in general, but it is literally a label that is now fixed to refer to one thing. It can't change it. So it's not a variable. Variable is where you can change what you stored associated with a label. This is a constant where you can no longer change what you stored. Does that make sense, YC? Okay, excellent. All right, so we've declared the label GeneratedFunk, but what the hell are we going to store on the right-hand side? What are we going to store here? No, that does not look like a question mark. Let me try that again. What are we going to store? Oh, I want to make it really big. That's fine. What are we going to store on the right-hand side here? What? I don't know. Well, who thinks? Oh, I should do a poll. Oh, I might do a poll. That'd be helpful. I've never done a poll before. Let's do a poll. Add a question. Oh, no, that does not. Oh, no. I've got to go to Chrome to add a question. That doesn't seem like a smart move. Okay, change of mind, change of mind. No polls, no polls, no polls, no polls. All right. What do we think is stored in GeneratedFunk? Raise your hand if you think it's create function. I didn't do my voice one up. Raise anything is create function. Jonas, thank you, my friend. You're so wrong, but thank you for getting involved. I know you're going to find the answer. Very exciting, Jonas. Who thinks it's the command to run create function? Ah, that seems reasonable. Wrong. Wrong. Thank you all for your contributions. Jonas, I hope you're now feeling good company. Who thinks it's the output of running create function, and until we get that output, there's actually nothing stored in GeneratedFunk? It's uninitialized. Kevin says yes. Shatavia, hello. She managed to come on video so she could show how well she knew that. Thank you, Tate. Nathan says yes. Let's see who else. Who else raised their hand? Carly says yes. All right. Michael says yes. Oh, hi, Sin Yi. I've seen your multiple applications. Hello, and it looks like you agree with this, so yes. Folk is exactly right. Sorry, Sin Yi, I think you're on mute. It's exactly right. Hi, Sin Yi, go ahead. How do I pronounce that name properly? I don't want to get it wrong.
I go by Uma, but you can call me Xingyi as well. Sorry for the late drop and for disturbing the class.
Excellent. Xingyi, you're spot on. Folk, this is what actually happens. We do not store anything in GeneratedFunk. In fact, we don't store anything in GeneratedFunk until we've headed off to run create function and see what its output is, and that's what gets stored in GeneratedFunk. Folk, this is already important stuff that may seem like, who cares? And I remember, now I just believe it matters so much because I've seen too many Codesmith grads have this level of understanding of JavaScript that gives them an unfair advantage. React becomes easy. My Node talk, I'm worried it's like, I don't know, if you get hard parts, you don't really need the Node talk because it's just JavaScript. So let's map this out. This is what actually happens. So we declare GeneratedFunk exactly as YC said, and we're going to have to run to execute create function in order to figure out what its output is and store that into GeneratedFunk. Now here's the question. How do I spot, David in Jersey? David, how do I spot when I run create function? What keyword am I looking for that will be the indicator of what the output of create function will be, David? Command Shift A, David, on a Mac, Control Shift A on a Windows. Go ahead, David. How do I spot what keyword tells me what the output of my function will be, David? I think David's on mute. Unfortunately, David, I think you're on mute, man. But I'm going to tell you, folk. Well, actually, maybe I'll call on Sam. Sam, go ahead, man. What keyword tells me what the output of my function is going to be? The output of create function is going to be here.
I'm sorry, your question is, what is the output of the...
What keyword is going to indicate always what the output of my function is? What's going to come out the bottom of
the parentheses.
No, is often the right answer. What keyword is going to tell me what the output of my function is?
Oh, the return.
Return. Well done, Sam. Good job, man. So we've got to go and then actually run create function. People, we're going to be there in a second. Don't worry. We're going to run create function because we're going to have it return as its output something very mysterious. And the returned out thing is going to have a superpower. A superpower on which more of our JavaScript code than ever is going to depend on us understanding. All right, so let's run create function. Whenever we run a function, people, we need to create almost like a mini app to run it. Here it is. It's called an execution context. That's what I'm doing here. I'm executing create function, and it needs two things to run. It needs a little mini memory of all the stuff that gets created while we're inside, and then we're going to go through its code line by line. This is known as the thread, which is just a posh way of saying we're going to go through the code of this function line by line. So what I did there is going to go through that code line by line. Whatever it says to do, it's going to do it. If it says to store something, it's going to store it in the local memory, not in the global memory, because we're inside the function. Okay, so let's do that. First thing it says to store, Kevin in SD, what's the first thing, if you can jump on, that it says for us to store as we go into create function? What? Have I got my mute on? No. Kevin, you're also not getting any noise. Nathan, I'm going to turn to you, Nathan. Kevin, you want to try and figure out your mic. Nathan, what's the first thing I'm going to store inside create function?
The function, multiply by 2 in local memory.
And assign to what? The function definition of multiply by 2. There it is.
Yeah.
Excellent. Well done, Kevin. No, not Kevin. Nathan, sorry, man. Okay, that function is being stored. People, that is the whole function here. And then here is its label. And that's the label stored. Okay, so two parts of storing a function, its label and its rest of its code. What are we going to do with that function? Who shall I call on? Shinyi, I'm calling on you. Shinyi, what are we going to do, or Uma, what are we going to do with that function? Are we going to run it? Are we going to run multiply by 2 inside a create function, or are we going to do something else? Take it away, Shinyi. What are we going to do?
I think we're gonna pass in an argument. That's my guess, but I might be super wrong.
Not far off, but what are we going to do, Michael, in New York?
I know we're not going to run it. I would imagine we're going to hold on to it and then return it, and it gets run at some, I don't know.
We saved it.
And we invoke it later by passing.
Emmanuel, you've just jumped on with your video, which suggests a confident disposition. Do you want to jump on, Emmanuel, and give us the answer of what's going to happen in this line?
We're going to store it on the memory, the general memory.
What are we going to do with it, folk, in this line here? So we've saved multiply by 2. We're inside of create function. That's where we are right now. We're inside the running of create function. We've saved multiply by 2 as a function inside of it. We're not going to... What are we going to do with it?
We're going to return it, and it's going to get stored in GeneratedFunk.
Aha! Good job to everybody who contributed to that collective effort. But well done, Michael, for saying the final piece. We're going to return not it. Here's what JavaScript does. It sees the line return multiply by 2. There it is. Sees return multiply by 2, and it goes, what's that? And it goes to look for it, and it sees it's this function definition here, the code of multiply by 2, and it's going to grab it, and it's going to return it out into the label GeneratedFunk. And there it is. You return out our function into the label GeneratedFunk. It was previously known as what, Michael? It was previously known as?
My multiply by 2.
As multiply by 2 is not going to be known as that anymore because we only returned out its definition, not its label. It said return. We used its label to find its definition. We then returned out its code, its definition, not its label. So we better give it a new label. Michael, what is its new label?
GeneratedFunk.
GeneratedFunk. Fantastic. Well done, Michael. I'm keeping them color coordinated. This is the same function. We didn't copy it. We just returned it out and gave it a brand new label. There it is, GeneratedFunk. Okay, and now we exit this execution context. We're done with it. And we head out where we hit what line? Kevin in San Diego, if you want to jump on, we hit line out here. What does the line say to do?
We're going to declare a variable or declare a label result.
A label, a constant result.
Which is equal to the output of the invoked function GeneratedFunk with the...
Exactly. But what the heck is generated? What was GeneratedFunk's old name, Kevin?
GeneratedFunk's old name was multiply by 2.
Was multiply by 2. Who feels that, I promise you, a lot of you feel that GeneratedFunk somehow has something to do with create function. Somehow GeneratedFunk has, because it says GeneratedFunk equals create function. It doesn't say that. It says GeneratedFunk equals go run create function and see what it equals. What did it equal? Well, it equals whatever came out the bottom of create function. How do we know what comes out the bottom of create function? We run it and we see what gets returned. What gets returned? And it says to return the whole function definition of multiply by 2, return it out and store it in GeneratedFunk. GeneratedFunk has nothing to do with create function after that line. It was a one-time running of create function. Run me once and see what I return. And it returned multiply by 2, but without its name, just not the label, it returned the function. And that got stored over here as GeneratedFunk. And the weird thing about JavaScript is that when you declare a label, GeneratedFunk, you can then put a function in it and then run that function by that label by just putting parens on the end. Very strange, but you're absolutely allowed to do that. And that's exactly what we do in the next line, where we declare a result and then we say, put parens on the end of GeneratedFunk. And what is GeneratedFunk? Let's have a look. It's the functionality formerly known as multiply by 2. So we create what's known as an execution context, which is just like a mini app to run the function. And we use the code that was formerly known as multiply by 2 to run it. And into it we go. And folk, here's where it gets weird. We technically have to look back up the code to where it's inside create function, where multiply by 2 was saved. Where multiply by 2 was written. JavaScript does not do that. In this line, that's what I hate about the online version. No, not that line. In this line, the one I just highlighted, we literally grabbed the whole code of multiply by 2 from inside of create function when it was running, returned it out, and stored it in GeneratedFunk. In fact, I'm going to show that, people, by look at this. I'm going to take this here. I'm going to copy it. I'm going to put it over here. So we really realize, look at that. GeneratedFunk is just multiply by 2, but without the label anymore. Now it's called GeneratedFunk. So when we run GeneratedFunk, we need to go and look at this code over here and see what's the input that we're expecting. What's the parameter, the placeholder, the name that we're expecting to fill in with something. Nicole in La La Land. Nicole, do you know what we're gonna pass in 3? We're sure of that. What's its label gonna be, Nicole?
We're gonna pass in 3 to the generated function.
Correct. What's its label gonna be, Shinyi?
It's result, isn't it? Or yeah, your thing was in the way. Sorry.
Shinyi, spot on. It's gonna be num. Nice work by Nicole and Shinyi. Thank you to both. It's gonna be num. GeneratedFunk is really what? Everybody type it in right now. What is GeneratedFunk really?
6.
Generated Funk. What is generated
Oh,
funk?
sorry. It's multiplied by 2.
Nice, Shinyi. Thank you for not going by what I just said, which was type it in. But don't worry, Shinyi.
Oh, sorry.
You're correct, so it's very nice. Michael, I wouldn't say it's return num by 2. It's, I see where you're going. It's the function. I would write this, people. The function that was formerly known as multiply by 2. The function definition formerly given the label of multiply by 2. Oh, I can't type that, but you know what I mean. Good job, Sam. The function definition of multiply by 2. I like that. Yes, exactly. Excellent, Sam. Sam, can you put your city up so everyone has their city up? And I want to... Tay, thank you for changing your name to Tay. I was very confused for a moment by Shatavia, but lovely to see you, Tay. Excellent. All right. So that means we go into that function and it says num will be filled in with 3. So there's num and 3, and then return num by 3, which is, no, not by 3, by 2, which is 3 by 2, 6. And we return it out into result. Well done to Shinyi for saying that as well. And there it is. Result is 6. Oh my goodness. The only thing you might be wondering is, or among other things, is why the hell did we declare multiply by 2 inside of another function running, then return it out, give it a really useless name, GeneratedFunk, only to run it out there anyway? Why did we not just define a function multiply by 2 in global memory? Why the hell would we define it inside of the running of another function, only then to return it out and then use it outside of where it was born anyway? Why? It's going to turn out, people, it's going to give our returned out function. The little baby function that was born inside, when it gets returned out, is going to have a crazy superpower that dominates JavaScript. And anybody who's just answered my obviously rhetorical question, what are you doing? Yeah, that's at least you're not directly answering, Michael. It's an interesting perspective, yeah. All right, people. So, folks, let's have thumbs on this. You lost me. I'm going to, wait, I'm going to do it one more time. So, I declared a function. I saved create function. We'll ignore the second line. Don't worry about it. We didn't use it. It was just to make a point. So, we saved a function, create function. We then declared a label, GeneratedFunk, which is going to have stored in it, associated with it, assigned to it, whatever comes out of running create function, not create function itself. Because of what symbols? Sam, in Irvine, this time, you're probably going to answer right. Sam, what symbols tell me? This is why I've asked everyone to focus. Oh, yeah, the only way to be, I obsess over people supporting the Codesmith community when they're in the broader community and supporting each other. The only way to do it online is to stay 100% focused. No watching to see what, oh, the game's already finished. No watching to see what the consequence of a 2-0 defeat to Tottenham by Chelsea was. No watching to see that Suarez scored 2 goals for Barcelona in the Copa del Rey. No watching to see that Liverpool won 5-0 with 2 by Mane, 2 by Van Dijk. No watching. No, you're focused on hard parts. On which note, Sam, what was the question? I forgot the question. Shit. Oh yeah, Sam, why do I know that I have to go run create function and store its result in GeneratedFunk, run create function, store its result in GeneratedFunk, not store create function in GeneratedFunk? Why, Sam? Sam, I literally gave you like 20 seconds of me repeating the question so you could unmute yourself.
Hey, Will, I couldn't hear you for some reason. Sorry.
Shit. All right, so let's try it again, Sam. Why, Sam, do I know that I am storing the output of create function in GeneratedFunk? So, Sam, I'm looking at this line here. Why do I know I'm storing the output of create function in GeneratedFunk, not create function itself? What symbols tell me I've got to go and run create function find its output, and store that in GeneratedFunk?
The parentheses.
The parentheses. Thank goodness. Good job, Sam. So let's go through it very quickly. No breaks this time. And then we need to understand this, and closure becomes easy. Get this down, closure's easy. We store create function.
Can I ask a question? Or I don't know how this works.
We declared a label. We declared, Nicole, give me a second. We declared a label, GeneratedFunk. We then ran create function to see what. We then ran create function. I'm going to do a brightly colored highlighter here. We ran create function, stored its result in GeneratedFunk. Well, what is this result? Well, we had to go and run create function. It said to save multiply by 2 and then not run it, but return it out into GeneratedFunk. And there it was, formerly known as multiply by 2, the function stored now in GeneratedFunk. And we then used it by its new label, its new global label, GeneratedFunk. And we ran it with the input of 3. That's what we did here. Passed in 3 as its input. That means we're passing 3 into the function formerly known as multiply by 2. Pass in 3, return out 6. And there it went into results. All right, people, let's have thumbs. You lost me. And it's tough, people. I'm clear. I have clarifications. Everyone's thumbs out. Emmanuel says she's clear. Tay says she's clear. Shinier, Michael, YC. Folks, throw your clarifications in, because if we don't get this, this may seem disconnected. But if we get this down, closure follows so easily. But if we don't get this down, it doesn't. All right, people. Okay, no clarifications. Let's move the hell on to...
Wait. I have a question.
Nicole, you had your thumb up.
Yeah, but I had to... if you could go back to that other slide real quick.
Okay, let's just go with Sahara first. Sahara, can you
okay.
Thanks, Sahara. Go ahead.
So I'll just unmute myself to talk. So one thing that I was confused on is when we're doing the second label, when you're doing create function, is there are we doing anything with that second label at all?
Oh, Sahara, thank you for asking that. That's helpful for everybody. No, that was just for me to show you that when we don't put parentheses on the end of, when we do not put parentheses on the end of create function, we just take the whole of create function and give it another label. But that's not what we're interested in. What we're interested in is running create function with parens, which say go run it, returning out the inner function multiplied by 2 and storing it in GeneratedFunk. Does that make sense, Sahara?
Yeah, and one more question with that. So when you do, if I were to call create, second label and then put a number inside of that, say the same way that I'm doing GeneratedFunk, can I also do second label and then put a parentheses inside of that?
What would I be running if I ran this? Sahara, what am I running? What function am I running when I run second label?
Oh, this makes sense, because not running anything because it's just the function definition.
Well, no, I'll be running what function?
The create function.
Create function.
Yeah.
So I'll be running create function. So where would I be passing in my 3, Sahara?
Into the num? Oh,
no.
Wait, there's no parameter there.
There's no parameter. So it would actually just be ignored.
Okay.
Create multiply by 2 doesn't get dynamically run by create function. When you run create function, you're going to save multiply by 2. You're not going to use it. So if you run second label, you're really just running create function. So you're passing in a 3 to create function, which has no space to receive inputs anyway. Yeah, Michael is right. We could technically do what he's describing there, but he's saying run create function, it returns out multiply by 2, and then run that multiply by 2 into 3, but we wouldn't get any of the special powers we want, Michael. So, we probably wouldn't do that. Nicole, go ahead with your question.
That answered my question. Everything. I was just curious, what was the difference? And then now it's very well explained. Thank you.
Beautiful. Thank you, Nicole. All right, here we go, people. Now we get to our final and most important code. I say final. We'll decide whether we do one more piece depending on time. But most important here it is. This code here, folk, is going to reveal why we want to return a function from another function at all. And we're going to discover it ain't going to work at first until we learn another major thing in JavaScript. And then it's all going to come together. Here we go. Look at this code here. I'm going to save a function. By the way, I love writing in white on black. Isn't that a kind of, I don't know, that's a very, very cool look. There we go. So we're going to save a function outer. Not going to run it there, are we? We're saving it. Then we're running it here. Whatever it returns out, by the looks of it, it's going to return out this increment counter function into my new function. Oh, that sounds familiar, right? My new function is going to now be a new label for the function formerly known as increment counter. We're then going to run my new function, and we're going to run it twice. And it's going to run this code here. I can already feel there might be some issues. Let's play it out. Let's play it out, people. Oh, let's grab the code. Let's grab the code. There it is. We're going to grab the code. Let's put it down here somewhere. There it is. All right, folk. Here we go. We're going to get some of my twin snakes. Don't get me wrong, people. Don't get me wrong. I've probably advocated for things before that have not become global phenomena. But there are two things that I've been a strong advocate for a long time. And I say this with a grain of salt of the awareness of the ridiculousness of me saying this. But Osuna has been my personal hero for 2.5, no, by now maybe 3.5, 4 years. This guy's my personal fucking hero. His music is the most beautiful. He was the most played musician, singer, pop star, whatever, on YouTube in 2018. More than Daddy Yankee. More than, I don't know, Quavo. More than Migos. More than anybody else, Osuna. The other thing that I've been advocating for a long time are these beautiful creatures. And now, every single store you go into, they have these magnificent creatures. I highly recommend them. Everybody knows the blue and red ones are the best. I'm going to have one right now. They have one that is sour and one that is sweet. Exactly. I'm with you. Doesn't that sound amazing? All right, here we go. Oh, I can see Wayans really engaged with my twin snakes repartee. He doesn't give a fuck. He doesn't care. He has no interest in my twin snake. It's spelled with a Z, Michael, but almost. Oh, they are good. Oh. All right, we go vote. So, line 1. Shinyi, you're doing great. Is this your first hard pass ever?
Not really. It's probably my second, third.
Okay. Well, you're doing really nicely. So what are we doing here, Shinyi, in line 1 of our code?
Line 1, we're declaring a function, or maybe it's a function expression. Sorry, I don't know the
As a function, definition's fine.
Function definition. That's called outer. We're giving a label outer that takes no argument. And within it, that function returns another function called increment counter.
So we never go inside of a function. We never do any of its code. JavaScript doesn't care about it until it gets what?
It gets called or invoked.
Are we calling it here?
Huh?
Are we calling it in line 1?
Are we cool in line 1? Is that what you mean?
Are we calling it in line 1?
No, we're not. No, we're not. We're just defining it.
We're not. Shinyi is paying me back for my mispronunciation of her name by misunderstanding my British accent. Saying a totally different word. No problem, Shinyi. All is forgiven. We are now even. And so we declare outer and we save it in our global. That means it's available everywhere. Memory. There it is. All right. Line 2. Who am I going to call on? Sahara. Go ahead, Sahara. What are we doing in the next line?
So in the next line, we're just declaring a new constant, my new function.
Well done, Sahara. We've got Amy there. Amy, do you have a mic? I'm going to call on Amy in a moment if she has a mic. Otherwise, for now, I'm going to call on Emmanuel in New York. Emmanuel, we've declared my new function. There it is on the left-hand side. What, Emmanuel, does the right-hand side tell us to do?
To run the function outer.
Excellent. So in the meantime, we're going to have my new function be uninitialized. It's got nothing stored in it because we've got to go and get the result of running outer. So we've got to create a new, what's known as execution context. There it is, with a little local memory. Oh, you know what, people? I have a nice, pretty execution context that I've got pre-made that will make my work much cleaner. Let's have a look. Where is it? There it is. There it is. Look at that. That's a lot cleaner, isn't it? That's a lot nicer. Let's just put this. There you go. All right, so we're running outer and into it we go. And what's the first thing it says to do? Dwayne, you're up, man. And then Amy. Amy, hopefully you're there. If you're not there, people, by the way, oh, please put in your name if you don't have a mic so I don't call on you. Otherwise, everybody gets the joy of sitting for 10 seconds, which feels like a long time online without you responding. So if you don't have a mic, please put it in your name. Otherwise, I will call on you and everybody suffers. Dwayne, go ahead. What's the first thing we say to do inside of outer?
We are declaring a let called counter.
You can call these variables, Dwayne, because they
variables. Okay. Called counter, and we are assigning it the value of 0.
Beautiful. So let people as a way of announcing a label where you can change out what you store in it whenever you want. So they call them variables because they can vary. Versus the const, which is a way of declaring a label for something that you're not going to be allowed to change later on. It's constant. It's fixed. All right. Next line. Kevin in San Diego.
So we have a function declaration of increment counter.
Beautiful. There it is. Stored. I'm going to color it in so we can recognize it at any time. There it is. All right. And now, Amy's still not said she's got no mic, so I feel I can call on her. Amy, are you there?
I'm here.
Hello, Amy. Excellent. And man, also calling you on the hardest bit. So, Amy, here we are. What's this final line of code here? What does JavaScript do? Sort of talk it out to me bit by bit. What it's doing in this final line, return increment counter.
It's going to return out the output of the function outer.
Well, that's correct, but by definition, it's inside outer, and so whatever it's going to, so what is it going to return out? So it says return out something. What's it saying to return out? What?
Increment counter.
Increment counter. But let's be a bit more precise. It says return out increment counter, and it goes, what's increment counter? It looks in memory and sees that it's this function, the code of increment counter. So I guess it's, yeah, it's, let me just highlight it. It's, or I'll do it in white. It's this bit here. That's what's going to be returned out. So let's go ahead and do that. Let's return that definition out into, Amy, what global, where's the output of outer going to be stored, Amy? Into what global label?
My new function.
My new function. Spot on, Amy. Thank you so much. There it is. So the functionality that was formerly known as increment counter is now known as my new function. And we exit out of this execution context. Excellent from Amy. Thanks so much. And now we hit the all-important line. My new function being executed. Before we do that, folks, I just want to add something else to the mix of what goes into JavaScript. It's called the call stack. And it's sounds pretty complicated, but all it really is JavaScript's way of keeping track behind the scenes of where am I right now in terms of my code. Am I inside of outer? Am I out here in the main file of code? Am I right? They call it the thread of execution. I'm going to do it in green. So it starts out here. It sort of weaves its way down. And then it goes into outer. And then when it finishes in outer, it comes back out. And then it goes into my new function and then comes back out. And then it goes into my new function again and comes back out. So it's what line of code is being done at any given moment. And when I finish on that line or finish in that function, where do I go back to? And when I finish in a function, I delete all of its local memory. It all gets deleted. So I went into this function, went through its code, came out. While I was inside the call stack actually track that. So I start off in something called global. So I'm always in global. That's the main file of code. I'm going to show that we're always in global. This whole thing is global. That's pretty ugly, sorry. So that's always on this call stack. So a stack is a way of storing information in a computer where its main purpose is to store things where all you care about is what's on the top. Like a stack of plates, you can't remove a random plate. I guess you could, but in theory you can't. You can only take the top one off. But when you do add one on top and then take it off again, what was there before should still be there. Well, that's quite a good way of modeling these execution contexts. That means the running of functions. When I start off in global, that's on the bottom. That means I'm running the main file of code. There it is. When I finish with the main, when I enter a function, when I run a function like outer, I'm going to add it, folk, to the top of my call stack. So while I'm inside of outer will be on top of my call stack. And like a stack of plates, that's all I really care about, the top. I'm not doing anything in global, I'm only in outer. When I finish in it and hit return and exit out, you might go, well, JavaScript doesn't know where to go. It doesn't know to go back to global and continue running. It does not know to go back and continue running this code here. It doesn't know that. Don't panic. It figures it out, because when it finishes running outer, it pops it, it removes it from the call stack and goes, where do I go back to? Don't panic. Whatever is top of the call stack, then it knows where to go back to, and it continues running the code in global. Global just means the overall file of all the code. So when it goes into a function, when it runs a function, it goes inside of it, and it keeps track of the fact it's inside of it by putting that, they call it pushing it, to the top of the stack of functions being called. The call, the call stack. And when it finishes running that function, it says, oh, remove that. Where do I go back to? Whatever was left below, which in this case was global, which takes us back out to global. So stacks are a good way of, you could model a Russian nested doll as a stack, because it's, all we care about is the top thing. We take it off and what was there before better still be there. Well, that's what this is. Cool stack, very funny, very good. Who was that? That was very funny. Good job, Michael. I appreciate this excellent joke. People, do not be confused by Michael. It's a call, C-A-L-L, a call, as we say in England, call stack, meaning it's a pile of functions being called. And the top one is on being called, being run right now. Finishing it, you go back to where you were before, which is what we're doing here. And out we go to hit the running, the calling, the execution of what function? My new function. And we're almost there, people. We're going to run my new function. Here it goes. Let's call on Volodymyr. Volodymyr, are you there? Does he have a mic?
Yes, I'm here.
Hello, Volodymyr. How do you pronounce your name correctly?
Volodymyr is okay.
The response every person looks for when they mispronounce a name. Volodymyr, so we hit the running of my new function. We are going to create an execution context for it and do what to our call stack? Volodymyr?
What is the question? What we do here?
What are we going to do with our stack of calls as we run my new function? What are we going to do to our call stack?
Here we call result of outer.
So we're running my new function. Emmanuel, we're running my new function. Thank you, Volodymyr. I just want to grab me, Emmanuel, on this one. We're running my new function, Emmanuel. What's that mean we're really running? What function are we really running, Emmanuel?
Increment counter.
Good job, Volodymyr. Emmanuel, you want to take it away? What function are we really running?
The definition of increment counter.
The definition of increment counter. I love that precision. Excellent, Emmanuel. Exactly. Thank you to Volodymyr as well. Good answer. And so we go into it. We create an execution context. Nathan, we're running my new function, so we better put it on top of the
call stack.
Call stack. Well done. Into it we go. We're running my new function within global. Folk, we are not running my new function inside of outer. Outer is dead. dead and buried. We're running it in global. We grabbed the definition from inside of outer of increment counter and we ripped it out and stored it in my new function. And that's what we're running right now. Increment counter's definition by its new name, as Emmanuel rightly said, my new function. Let's get running it. What's the first line of code it says to do, Emmanuel? What's the first line of code when we run my new function that it says to do?
Well, it says to increment counter, but like I don't understand where we declare it.
Oh, Emmanuel, this is fast-moving thinking. Excellent. Well, where would we look? I'm going to use not green. I usually use green, but I use that for my thread. I'm going to use pink for my lookup journey that JavaScript does. Where does it always look first, Emmanuel?
In the global memory.
It doesn't look first there. Where does it always look first? When I run a function and I'm looking for something inside of it, where do I always look first?
I don't know.
So I'm running my new function. Sam's right. Sam says, I look in the local memory, right? Emmanuel, so if I'm running my new function, I always look for something in its local memory first. Did I define it there? And the answer, Emmanuel, is?
No.
Correct. I did not define it there, so it's not in my local memory. So it's not in my new function. Where would you say I look next, Emmanuel?
In the global memory.
That sounds right to me. Is it there?
No.
No, it's not outer. It's not my new function. Those are the only things to be saved in global, so it's not there. Damn. Always in that order, Shinyi. Yeah, always local out.
Question.
Huh. I feel pretty depressed now because we've gone through all of this. It's not even working. Huh. It's a shame. Huh. Hello, Archie, by the way. We'll use this as a chance while we feel frustrated and sad. Say hello to some people. Hello, Archie. Sam, please, can you stop preempting, stop live tweeting this event? Oh, I appreciate it, Sam. All right. Huh. I'm puzzled. What a shame. This could have been a really good talk. Now, we don't even have our counter. Yeah, so depressed, Sam. Shinyi, don't. Shinyi, look. Sorry. I'm muting you, Shinyi. I can hear you typing. All right. I'm very sad. I'm very, very sad. By the way, so Codesmith is all about the actual outcomes, these extraordinary outcomes. But unfortunately, the ridiculous legal bullshit that comes out of whatever, we have to give out diplomas. Oh. Diplomas mean nothing. The outcomes is what people, you know, the extraordinary leadership that Codesmith grads take on is what counts, not a damn diploma. But now, in order to have a diploma, we have to have, to make sure nobody imitates our diploma. Oh. Anyone wants one of these? I'll give you one of these right now, no problem. I'll give you one. I made a little certificate. Where is it? Here it is. Yeah, you want one? You want one? You have it right now. Ridiculous bullshit, licensure bullshit that doesn't understand what actually matters. Waste of my time. Anyway, I think I probably broke all sorts of rules by complaining about that. There we go, never mind. So, what a frustrating situation. What a frustrating situation. What a frustrating situation. Okay, yes, Nicole's getting impatient. What is going on? I agree, Nicole. I mean, broadly, what is going on? Why am I just complaining about pieces of paper? That, I think, is a very, very fair question. But also, what is going on with this shit here? What's going on? Here's what happens, people. I'm not going to drag it out. I'm not going to drag it out. Here, folk, is what happens. It's pretty damn cool. So, it turns out that when I ran outer and returned out into my new function, increment counter, and I'm now running increment counter by its new name, my new function. I'm running my new function, which is really increment counter, which has got this counter plus plus in, and yet I can't go back and outer. No. Outer's memory's gone. As Emmanuel said, I can't go back up into outer. I looked in my new function, there's no counter there. I looked in global, there's no counter there. So where is counter? It turned out that when I returned out increment counter into my new function, I brought more than just the function definition. I brought all of the surrounding local memory attached on to the function. I pulled out the function and I brought with it, attached on the back of the function, kind of on the back as the function came out, I brought with it all the surrounding memory. There it is, attached onto the function. Literally, not counter is set to be 0 or assign counter to 0, but literally stored in memory, counter is 0. I call it the backpack. Let's just draw a little backpack because it's on the back of the function as it comes out. As the function comes out, it grabs the data and brings it out on its back and stores it in the new global label, my new function. So yeah, Emmanuel was so right. First, I look in my new function's local memory when I run it. But before I go out to global and then find that there's no counter there, I first sort of insert myself in the way between my new function and global, and I look into that backpack of data. And what do I find there? Counter is 0. What do I do to it? I increment it to 1. There it is. And then I guess I exit out of my new function. And if there'd been anything in local memory, it would have been deleted. Let's run my new function one more time and see what happens. So we go back out to global. We're no longer running the first running of my new function. We delete it from the call stack. We go back out to global because that's where we're running my new function from. And we hit our final running of my new function. There it is, or our second running of my new function. We create, we got to create a brand new, I should make you all say this together because it's my favorite thing. You hit it, you're running my new function, we create a brand new
execution count.
Thank you, Dwayne. The rest of you should be more like Dwayne. He's a hero among people. Look at that. I didn't say the traditional phrasing of that.
Look at an adapter too late.
Good job, Cliff.
Oh, got it. It was already typed.
Good job, Cliff. There it is. And we run my new function again.
For the next 30 minutes.
Let's see, people, what happens when we run my new function again. Well, firstly, Emmanuel, what happens on my call stack when I run my new function?
You get pushed on.
Cliff, I'm going to mute you. I asked Emmanuel, but I promise I'll come to you. Don't worry, Cliff. Emmanuel, go ahead. Poor Emmanuel's been spoken over 3 times. That was me the 3rd time. Emmanuel, go ahead.
You get my new function on the top of the call stack.
Beautifully put. Thank you, Emmanuel. And we enter its execution context. And what's the first line it says to do there, Emmanuel?
It takes counter. It's increment counter, sorry.
This time, Emmanuel, you talk me through. Where do we look first? Always, where do we look first? For counter.
Oh, yeah.
Where do we look for it first, Emmanuel?
Local memory.
Do we find it?
And then to the...
Or do we find it? Do we find counter in local memory?
Oh, no, sorry.
We do not. Nothing in local memory. Do we look to global next, or into the global names, global labels next?
No.
No. Where do we look?
In the function definition of my new function.
It's not the definition. That's what we're running. The definition has attached to it a backpack of data. And that data, that backpack is where we look. We'll get the posh name of backpack in a moment, but we look into that backpack where, what do we find, Emmanuel? Counter is?
1.
Counter is 1. And we increment it to?
2.
To 2. Wow. People, we now have access in our function, attached to our function definition, to data that is permanent. That's attached, as Emmanuel rightly said, to our very function definition itself. Let me make sure this is not implying that it's out there in global, we increment 1 to 2. There it is in our backpack of data attached to the function, my new function. Our function, my new function, now has a memory. We could use that counter. We could say, you're not allowed to run my new function more than 2 times. So go check in the backpack how many times it's been run. It goes up, counter goes up by 1 each time. And if it's over 2, return out from my function, sorry, you can't run me again. You've already run me once. Our function gets a backpack of live data, a permanent memory. And people, this is going to change how we write code. We're going to see how in a moment. But first, let's talk a bit about this backpack. It's the most important concept in JavaScript. So you might think it's in global. The data counter looks like it's in global. No, we cannot access it in global. We can't go counter in global. You can't refer to counter and hope to look into global and find it. No, 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 no. It's not actually in global at all. I mean, it's sort of in global. It's bundled up, protected inside my new function as a label. So the why I disagree with you, Emmanuel, that counters in my new function's definition, it's this. My new function is now got 2 parts. Its definition and the appendage of the backpack of data. It's those 2 parts together. I'm going to do a little plus sign between them. It's the function plus the associated live data. And you might think, well, maybe we can do this. Maybe we can write my new function dot counter. Nope. Maybe you can do my new function dot backpack dot counter. No. Maybe you can do, I don't know. Well, maybe once we learn the proper name for backpack, we could refer to it by that. No. We cannot get access to that backpack of data. It's only available by running my new function, running its code, and inside referring to something that's not in local memory, and then off we wander to the backpack, and that's where we can use that data from. So we have to make sure that we wrote increment counter correctly, such that when it gets returned out, it makes reference, it has a reference, it refers to something, that's what counter's doing here. It asks for something, it goes looking for something that's not in its local memory and has to go out to its backpack. But if we do that, people, we've given our function a permanent memory. This memory gets deleted every time, which is pretty rough because we want to be able to have data that's stored in between runnings of functions. It's going to turn out to be absolutely vital, people, in JavaScript for our functions to have a permanent memory. It's going to change completely how we write code. No longer do we have to hold data in global memory for it to be permanent, and we don't like using global memory, like putting a label in global memory like result, or your team wants to overwrite that with their own results. So instead, where do you put data you want to hold on to forever, but you don't want to pollute the global memory with the names, with labels that other people are going to want to use? Don't worry, you put it in functions backpacks. It's permanent because the function is permanent, but the data is protected from others accessing it. What that also means, folk, is I'm going to talk about a couple more things. How is the backpack stored, and what are the posh names you can use for the backpack that will get you those mid-senior developer jobs? I'm not even joking. Google's #1 question to ask about, as I said, is about this concept. And if you use the 2 posh names I'm going to give you for it, I think they're going to lay out the red carpet. I think they're going to say, you, Mom, are what we've been waiting for. We've waited, we heard rumors of an engineer like you who one day would apply. We heard rumors, we heard myths, we thought they were legends, and now we see that you are real. Indeed, we're going to learn those 2 names that will give you that sort of edge in just a second. But first, a couple of things about this backpack. I'll hold on one thing actually, because I think someone will ask a question about it. I want to see people ask a question. I'm going to give us the name of it and how it's created. So, when we saved increment function, hold on. When we ran outer, went inside of it, saved counter, saved increment counter, immediately on saving increment counter, we immediately made a link under the hood to the surrounding local memory through a hidden property on increment counter, hidden beneath the scenes of JavaScript. Here it is. I'm going to write it out. A hidden property, which was, no. How do you do a very small, whatever. A hidden property which attached the local memory to increment counter, the function definition that was just saved in memory. It had a hidden property on it, square bracket, scope, square bracket. You can't do increment counter dot square bracket, square bracket. You can't do that because it's a hidden property built into JavaScript under the hood. But that's how it's linked. It links to the local memory. And then when we return out increment counter into my new function, that is when we return out increment counter into my new function, it brings all that local memory that was attached on its scope property with it in its backpack. But that also means, folk, we know, I appreciate Dwayne, he literally messaged us to say he's bouncing for a second. That means, folk, that we know, or JavaScript knows, when we return out increment counter into my new function, when we return it out, we already know all of the stuff that my new function, the returned out function, could ever refer to, could ever ask for. Shinichi will come to it in a second for sure. All of the stuff we could ever ask for in that local memory, in that backpack, because we can look at the function as it gets returned out. JavaScript does. When we return out this, I was going to tell you that in a second, wasn't I? I'm going to hold on that thought. I'm going to see if you've got any questions on it. So it's linked in the scope properties. When we return out the function, we bring the backpack. Let's talk about what the backpack's called. Let's talk about the fancy name. So first name that I love for the backpack is, well, of course, backpack. And by the way, we know now that this is a very popular name because of the wonders of, oh no, because of the wonders of, let's just do it, let's open it, Google, good, like Google, and we're going to search closures backpack, JavaScript. Here it is. I never understood JavaScript closures until someone explained it to me. Like this, what? 36,000 likes? It was 24,000 likes 2 weeks ago. That is out of control. Okay, so this is a guy at New York Times, very nice guy. We love this guy. He used to come to Hard Parts. He's now at the New York Times as an engineering manager. He'd come to this Hard Parts maybe 2-3 times. And look at this. He refers to the backpack. I want to show you that the backpack's not a crazy name anymore because it's becoming, he refers to the backpack 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Look at this backpack analogy. Stop appreciating, look at this guy, Vijeth. I came up with the backpack. Never mind. All I want is people to understand it. But the backpack is an emerging term. It's going to be in the JavaScript spec, the rules of JavaScript very soon. Do not fear. But let's get the fancy ass names. Here's one that I like. So some people call the local memory of a function when it's running, not local memory, they call it variable environment. So the variables is the old school name for labels, and it's the environment is anything around me, the place in which I do something. Well, these are the variables around me as I run the function. They're the data around me. So there's a term which I quite like for the backpack, which is that data, that variable environment, those data, the numbers, the stuff you stored around me, like counter is 0, is closed over, kind of protected. And when the function gets returned out, it closes over. When increment counter gets returned out, it closes over, encloses the variable environment around it and pulls it out into the backpack. So some people have called it the closed over variable environment, or the cove. I don't mind that. It's all right. I'm going to give you a better name. I'm going to give you a name that's going to blow people away. I say that. I think it will. Who knows? Maybe it won't. And that's this. So and the backpack is data, right? It's numbers, it's stuff stored, data. So it's data that persists, permanent or persistent, means it sticks around, it's not being deleted. It's referenced from the function, it's linked. Reference just means linked. It's referenced from the function by a property on the function. There's a function pulled out, brings with it the property, the hidden property scope that is attached. Behind the scenes is it's a name of the link to the data, to the backpack. So it's persistent reference data through the scope property. So persistent scope reference data. Okay. And it's a special type of scope. Scope is just a posh word in computing, meaning what data do I have available to me at any given time? And one rule of what data I have available to me is what's known as lexical scoping, which is where what data I have available to me at any given time with my function when I run it is what data I had available when I birthed that function. When I first saved that function, what data was available around me is always going to be around me, always available to me whenever I run that function. Even if I grab that function and return it out of where that data was obviously available, I'm going to still have access to that data, not because I can go back into that function, but because I'm actually going to bring the data with me. And that's known as lexical scoping, which is the rule of the game saying what data will be available to me when I run my function is what data was there when I was born, when my function was born, when it was saved initially. Why? Because I'm going to bring the data with me on my backpack. So it's persistent lexical scoped or lexically scoped reference data. Persistent lexical scope reference data. Lexically scoped reference, yeah. Okay, folk, there it is. Thumbs. You lost me a long time ago. This is a hard session, people. We do it in the New York Times, they don't get this. That's why this guy, the New York Times guy, wrote this big article on it. I'm clear. I've got clarifications. Yeah, persistent lexical scope reference data, exactly. Emmanuel's got clarification. I look forward to hearing it. Emmanuel. Sam, where's your mind at? Sam's clear. Shinji's got a question, clarification. Carly's clear. Michael is up, is clear. Cliff says, the Herschel. Nobody knows what that means, Cliff. I don't know what that means. Maybe everyone knows what that means, besides me. Tay's clear. Shinji, I saw you raise your hand earlier, so I'm going to come to you first. Shinji, can you jump on?
Oh, okay, thanks. I was wondering if do they take everything in the function outer and piggyback it into the backpack?
Beautiful, Shinji. What a fantastically sophisticated question, and exactly why I didn't give that answer earlier, because I knew there'd be someone in the audience who would have that intellectual curiosity to identify that very intriguing question. And I know lots of people will be thinking that as well, but thank you, Shinji, for stepping up on that one. The answer is no. So this is sort of what I was starting to talk about, and I thought, you know what, someone will ask it, so I'll let you ask it. Thank you, Shinji. So no, not all of the data here gets pulled out. Here it does, because there's only one thing, counter is 0. But everything else, if we'd saved something else, suppose, Shinji, that we'd said in here, equals 7.
Mm-hmm.
Well, when I return out increment counter into my new function, at no point inside of increment counter, my new function, do I mention Shinji. So why would I store it in the backpack? Because I can't get to the backpack any other way. I can only get it by running my new function. So as I return out the function, I already know all the stuff I could ever access from the backpack by looking at the function definition. And JavaScript does do that. The JavaScript engine, the Chrome JavaScript engine, the V8 engine, as it's known, when you return out the function, when the function gets returned out, it introspects it, it looks inside of it, sees what gets referenced. It sees that Shinji wasn't referenced. Don't hold on to that in the backpack. Leave that behind and delete it. Make sense, Shinji?
Yep. And I have a second question, but I'm going to be quick, if that's okay. Does it matter which order it comes in first? Like, if I put let counter equals 0 right on top of return increment counter, is that going to give me an error?
No,
or they don't care.
This scope bond, this scope reference, Shinji, is a link to this data. I mean, you can change this data as much as you want. What persists is the link. It doesn't sort of grab the data and copy it. It links to the data. So you could add it anytime you want. You could add more stuff underneath here, and it would all link to it. Great question. Emmanuel, I think you had another question, or was that the one you were asking? Emmanuel's clear. Shinji, Emmanuel was going to ask the same thing. Great job, people. Were there any other questions? Any other?
I have one.
Yeah, go ahead, Michael.
Sure. So in this instance, you have constants minus function equals outer, and you're executing the function.
Whoa. Forgive me, man. That sort of precision is so important. We have minus function equals the
calling of the outer function.
No, let's go one more level.
Oh, sorry, the increment counter.
The return
the
return of outer, which is the function increment counter.
Correct.
And this is why technical communication matters so much, because it makes your own mind more
precise. Absolutely, I love it. In that case, in the previous example, you had a parameter in that inner function, and my question is, if you called that parameter, so if you, in this example, let's suppose you had a parameter in increment counter.
I understand.
And you passed something into outer in this case, would it return the results? And if so, why?
To be clear, the premise is not quite there, or not quite right. So increment counter, if it had a parameter, the inner function, well, that would be, so we had a parameter in here, let's say, I don't know, Mike, then we would want to have, because increment counter is my new function, we want to make sure we're passing in something here, right? Like
Correct. So let's say there was a Mike variable within that function.
Within which function?
Increment counter. So that Mike was a viable parameter.
Yeah. The more in it is, the closer it is, the more it gets priority. So the Mike parameter would take priority. So if you declared Mike equals 3 here, then your backpack would have Mike is 3. But because you've got it as the parameter name here, it's in the local memory, you pass in 3, it would take precedence to one you passed in here.
But if you passed in 3 in outer, in where it currently sits next to my new function, what would occur?
If you passed in 3 here and you had a parameter Mike here, well, that would have nothing to do with increment counter unless you passed it through. Or you saying we'd have Mike here as well?
I'm saying you would have Mike in increment. Oh, I see. Okay. I think I just answered my own question.
Yeah, I mean, I think it would not get passed through. The locally one would take precedence.
Okay.
Okay. All right, people. So let's just get rid of that. I've got Mike written all over this right now. All right. How many times I press back on this? Okay. There we go. All right, people. I think at this point, let's see what my friend is saying in terms of time. Downstairs or here? Shall we do it? Let's see what he says. Because I think, because this is it. But we could talk briefly about this. Individual backpacks. I'm going to at least tell you, and you can go and explore this yourselves. Which is, what if we ran outer? So all this code is the same, folk. But what if we ran outer again, stored a brand new increment counter function into another function? Oh, wow, he says, I said, are you downstairs? Because there's a restaurant downstairs I like to go to on these nights. Or even here, he says, not yet, leaving now. I don't trust the end times of your talks anymore. Ha. Ha. Ha, ha, ha. Hilarious. All right, so if I ran out all over again, thanks, Carly. What is wrong? What is wrong with all? I give you this free content with only the small cost of going on about Codesmith graduates' outcomes. It's the only small cost you pay for this. And Carly sends undermining message. Oh, outrageous, Carly. After I bought you a food. Carly was, I was meant to meet Carly to talk about, well, I suppose, what was it? It was sort of a mixture of her software engineering aspirations. Maybe Carly also, we talked about overcoming some of those bullshit age biases in the industry. I hope you don't mind me saying that. I think people should know about the bullshit age biases that are out there. And we talked about some of the strategies to overcome that. It was meant to be before hard parts. It was my birthday evening. It ended up being after hard parts at something like 9:30, 10 p.m. And it was how I spent my birthday last year. So I was very grateful to Carly for that, the opportunity to talk about job search strategy at 10 p.m. What more could one ask for a birthday night? And people were queuing up to have birthday drinks. No, nothing, no plans at all. So I was very appreciative of Carly for that. Happy birthday, Dwayne. I know that you are a popular gentleman, so I'm sure you, unlike me, had plenty of plans on your birthday night. Yes, yeah, Sahara, same thing, correct. Okay, people. Lovely message from Shinji to Dwayne. Excellent, people. Here we go. So, if I ran outer again, well, maybe we quickly add it on up here. Yes, I think we can squeeze it on. Let's squeeze it on. Let's copy this and let's very quickly show it. I think we can afford to. My friend is, well, he isn't giving me an ETA even, so let's do it. And if he has to wait, he has to wait because it's become very boring recently. So we'll put this on over here, squeeze it down. There we go, there it is. Oh, whoops. Oh, no. This is our final piece, people, do not fear. There it is, okay. So we're gonna run outer again. I'm gonna do it very small up here, folks. Hopefully you can see it. So declare another, I'm just continuing my code, my diagramming up here, right? I'm not actually, doing anything special. Declare another function. And it's going to be the return value, the output of running outer. So everyone together, meaning Dwayne, I'm going to create a brand new
execution context.
I heard some good voices there. Shinji, I did not hear your voice.
Oh, sorry, I mute myself because I was typing and I don't want to. Sorry, I was typing.
So we're going to create a new execution context for outer. We're going to therefore add it to what, Nathan? I'm going to add the call to outer. When I call outer, it gets added to the what?
The call stack.
Call stack, well done. I go into outer, and what's the first thing it says for me to do, Nathan? As I go
declare a counter variable in local memory, set it to equal to 0.
Hold on, let's keep going with you, Nathan. Next line.
Declare a function increment counter, save to local memory, and then return that definition.
Beautiful, man. But I'm going to ask you, does it do anything else? When I, hold on, sorry, everyone. Does it do anything else? There's our increment counter function. Anyone want to tell me, as soon as I declare a function, what immediately it might bond to? Anyone want to jump in and tell me that? Nathan, do you have an idea? As soon as I declare a function, we saw it earlier, as soon as a function is declared, what, Nathan, does it connect itself to?
The backpack of local memory.
Well, the surrounding, at that point, I wouldn't call it a backpack so much because it's not being pulled out as the function comes out. It's like literally just the data. But I guess, yeah, backpack. But it's the local.
The scope?
The local memory. Sometimes, Dwayne, they call it the scope. I prefer to call it the local memory. The surrounding local memory immediately gets a bond. Exactly. Well done, Dwayne. We now, in the final line of running outer, do what? Kevin, what do we do in the final line? We're running outer, we've saved increment counter, we've saved counter, we've had increment counter, immediately get a connection to its surrounding local memory before we do what, Kevin?
Before we return it?
We return the increment counter function out into, Kevin, what global label?
In this case, another function.
Another function, excellent. There it is. Into another, that's called another function. And so now, people, the big moment of truth. We call another function once. We call another function again. We've called my new function once. We've called my new function again. We call another function once. We call it again. The first time we called my new function, our counter went up to 1. Suppose we console logged it. Suppose inside of my new function, we wrote console log counter after we incremented it. So what will we see in our console if we were to console log the values of counter from running my new function once, my new function again, another function once, another function again? Everyone throw it in the chat. Feel free, if somebody wants to raise their hand, I'll call on them. Let's call on Michael. Michael, we run my new function once, my new function again, another function once, another function again. What are we going to see? We've run outer to get another function and its backpack. We've run, oh, yeah, we should have pulled out the backpack with it, shouldn't we? We should have pulled out the backpack with it. Out it came. Out it came. So there it is. We run, connected onto the function. We brought out increment counter into another function. We pulled out its backpack with data with it, with counter is 0. So Michael, if I ran my new function once, my new function again, another function once, another function again, what, Michael, would I see in my console?
1, 2, and 1, 2.
What? And why would that be?
Because the backpack is tied to that specific function each time.
And exactly. We get one backpack for my new function that came out of the outer call the first time, our first increment counter with its own unique local memory. And then we ran out all over again, got a brand new local memory in which we had another counter which was set to 0. We pulled out the function, we returned the function out, brought out the counter as 0 in the backpack, ran another function, incremented that counter to 1. Ran another function again, incremented that counter from 1 to 2 in the backpack. Distinct functions with independent permanent memories. People, this becomes, as you write more advanced code, a major factor in how you organize and structure your code. Every single function is no longer just code to run me, and create a little local memory that's temporary. Now it's code to run and data stored, attached to it, unique to that function. And people, in coding, all we really do is save data and run code on it. So it's pretty damn powerful when you can combine that in a function under one label. A label becomes something labeling a function and its store of data. That changes, that's a good dream. The two things we do in coding, which is run code on data, we get to combine them in one. Function code to run by putting parens on the end of the function name, and then data attached that can only be accessed from inside that function. I mean, tell me what more I need to write code. That's it. And that's why in the end, so much of JavaScript basically does this. Everywhere, iterators, asynchronous JavaScript, module pattern, modularity in Node, they all, ifs, which are immediately invoked function expressions, they all depend on function getting its own persistent store of data bundled up on it in a backpack. Very nice, Michael. Let me ask a quick couple of other questions. This doesn't respond to my ETA question. Jesus. Quick couple of other questions. What if instead of defining counter in outer's respective local memories so that they end up in the returned out functions backpacks, they get pulled out, what about instead if we define counter inside of increment counter, such that each time I ran my new function, other function, I had a counter of 0 in my local memory? What would I have seen in my console for those 4 runnings? Anyone want, yeah, Shinji is, anyone else want to jump in on that one? Well, Shinji's right. Oh, David says 1, 2, 1, 2. Huh. So David, when I run my new function, if my counter, so increment counter got returned out into my new function, so I run my new function, I'm going to start off by saying let counter equals 0. So I'll have a counter equals 0 in my memory. Then I do counter plus plus goes to 1, and I console log it, I get 1. Close that execution context. The next one, let counter equals 0, counter in the local memory, increment it to 1. The local memory always starts from scratch, David. So it would be every time it would be 1, and then 1, and then 1. What about, folk? Here's an interesting one. What if instead of defining counter and increment counter, and in fact we're not going to define it even in outer, we're going to define it globally. Counter equals 0. It would be up here in global memory. What now would happen if I were to run my new function, another function, another function? People throw it in the chat. Very nice. Hamadou, always a pleasure to see you. Shout out to Nigeria. Hamadou, I hope you're listening to my emerging favorite artist right now, Tenny. I'm going to make you all listen to Tenny in a moment. Do not exit the video chat. Tenny is changing music. She won some big Nigerian competition last year. She is a fucking queer inspiration. I adore her. Very special. All right, people, there we go. So, folk, good job, everybody in the chat. Let's have a look at how you all did. Lovely 1, 2, 3, 4, 1, 2, 3, 4. Well done. Yes, Michael says 1, 2, 1, 2. Sahara says 1, 2, 1, 2. Dwayne says 1, 2, 1, 2. Claire says 1, 2, 1, 2. Shinyi says 1, 2, 1, 2. Nathan says 1, 2, 1, 2. Very nice, people. And then once we go to the local one, we have 1, 1, 1, 1. All right, folk. So let's have a look at the final slide. What does Clojure let us do? And Michael, you asked about performance there. This has no real, you're still doing the same coding. Most things, Michael, that you do in coding aren't really about computer performance so much as they're about developer performance, making your code tidier, better organized, more reliable, easier to work with. Because the hardest thing in modern development ain't performance, it ain't efficiency. Most of the time, computers can deal with the problems we're trying to solve. It's the developers. We need as much organizing structure as we can get, and this is the most important way of doing it. All right. So, we're doing well for time. So here we go. Clojure gives our functions persistent memories. First thing we can do with this, helper functions like once and memorize. So if I now have a function, like my new function, that remembers things about the previous running. It remembers that last time it was run, it counted to 1. Next time it's run, it incremented to 2. Next time it's run, it remembers it's now been run 2 times because it's got a counter at 2. So we could write code in my new function that says, if I am run more than once, in other words, if counter is greater than 1, it's been run before and incremented to 1, don't allow me to run my code. So we can imagine a once-ified version of multiply by 2. So I'd run it with 3 first time, it would return out 6. It would increment a counter in the backpack to 1. Next time I run it with 10, it doesn't return out 20. It would return out, sorry, you've already run me once, because it looked in the backpack and saw counter's already 1. Once-ifying functions, limiting them to only run once, is a super powerful and standard practice in engineering. If you're building a tic-tac-toe game, you don't want to allow someone to run the function when they click on the cell in tic-tac-toe to change it from O and then to X and then to O and then, no, limit to once. So you once-ify the function. So it can only run once on that cell. And how do you do it? You do it by storing in the backpack. You've already run it once. Memoization, a big part of computer science, actually, which is actually about performance. I take it back. There's stuff about performance here as well. About performance, how wasteful are we when we have a really slow function like nth prime? Nth prime would take in 1,000 and return out the 1,000th prime number. Takes in, 155,000, returning out the 155,000th prime number. I mean, that's going to take a long time. So if in your app you've had to work that out and you've already run the function with the input of 155,000, you do not want to have to run it again with the input of 155,000. You want to have it such when you run it with 155,000, rather than having to recalculate it the first time you ran it with 155,000, you, yes, did the complicated calculations. It took a couple of seconds, but before you returned out the result, you stored 155,000 and the result as key and value in an object in the backpack. So next time you run nth prime with 155,000 as the input, don't do all the hard work. Look straight in the backpack. See the result sitting there from when you last ran it. Grab it and in one step, return it out. Not millions of steps, not billions of steps, but one step. It's known as memoization. It is an absolutely standard practice in modern, it's the computers. You only get a computer science degree. In the first, year or two, you will cover memoization in a big way. It's the most important optimization to save you redoing hard work you've done already. It relies on storing data in the backpack. So next time you run the function, it's got a little persistent memory of its hard results from previous runnings. You've done it once, you don't have to do it again. Very powerful. Super powerful function memorization. Next thing it lets you do, iterators and generators. We don't have too much time to talk about this, but it's one of my favorite modern concepts in ES6. If you want to build iterators, a way of accessing data other than for loops, collections of data like arrays, you don't have to go and grab each element one by one. It wouldn't be nice if you had a function that kind of stored under the hood of it the underlying data. And when you run the function, it grabbed it from the backpack, each value, and gave it to you, rather than have to go to a for loop and get each element one by one. They're known as iterators. All iterators are the built-in versions of functions with a backpack of data where your underlying collection of data is stored. Very powerful. Generators, which are even more powerful than iterators, where you start going, hold on, if I'm just going to think of my data as a flow towards me, when I run a function, it gives me data, run a function, it gives me the next value. I don't have to go to get data from stored memory. It just comes to me. Well, why wouldn't it be cool if I could control that flow of data? You've heard of streams, you know about flows of data being given to you in a language rather than having to go and get them. Well, generators are flows of data to you that you'd have to go and get, where you can dynamically change them as they come out to you. And if you want to have them dynamically change based on interactions with a database, they're known as async await. Async await, the most powerful new feature in JavaScript, rests under the hood on closure. Oh, I didn't tell, I should have said the backpack's actual name. Oh, I mean, not the actual name, the name everyone uses for it. Everyone calls it the closure. Sorry, everyone. It's called the closure. It's an important thing. I don't like that name for it, but people call the backpack the closure. And the whole concept is called closure, which I don't quite like. But if people call the backpack, they say put it in the closure. Yeah, sorry about that, people. There we go. Forgot to mention that bit. All right, there we go. Closure. That's the backpack, the backpacks. All right, final thing, module pattern, or penultimate thing, module pattern. Preserve state for the life of an application without, yeah. So if you're writing clean code, you do not want to store in global memory the label, the variable result, because your whole team wants to overwrite that. And 100,000 lines of code, 200 developers, the VP of engineering, she don't like it when you call it all the same thing. So where do you store your permanent labels? Because you want to store data for the whole of your app. Where do you store them? You store them in the backpacks, in the closure. And it's known technically as the module pattern, a bit more organized way of doing it. Asynchronous JavaScript, promises, async await, they all rest under the hood on the backpack known as closure. All right, folk, it's been lovely having all of you. I have two things to share with you. One, oh, it's the end. On Thursday nights, Hard Parts is always followed by wonderful drinks and pair programming and meeting other developers who are aspiring or already in industry or in Codesmith right now. Let me just go and get my beer. That's my way of celebrating the end of Hard Parts on a Wednesday night. Which one should I choose, you might ask? Let's have a look. Well, we have a 2 rows Lil Heaven. Well, I've already answered the question. I want this one. Okay, Session IPA. That was answered. I like Session IPA. I didn't know it was a Session IPA. They're my favorite. So they're the lower alcohol IPAs, but also lighter. They're less hoppy, I think. I love the hoppiness, but I tend to like a little bit lighter. It doesn't say what. Oh, 4.8%. Yeah, 4.8%. The IPAs tend to be more than that. This is a lovely 4.9%. Oh, wonderful. All right, so 2 things to add. 1, what next? Career workshops. This is my favorite workshop to give, how to get hired as a software engineer. If you've been to it, I hope you've enjoyed it. As I told you, I think this guy Youssef told me he's got a mid-level job, which means a 6-figure job, without going to Codesmith. Boo. But he said hard parts, but more importantly, how to get hired. That workshop was the critical factor. Sahara, right now, also not going to Codesmith, also attended How to Get Hired twice, told me yesterday her resume is significantly improved. Have I got anything from it? No, besides the pure pleasure of knowing Sahara. Is it worth it? Probably just about yes, because Sahara is clearly a delightful person. But it's pretty borderline. I received no monetary compensation. Ah, well, life goes on. I hope you're doing well, Sahara. And I always celebrate your achievements. Very nice. Good. how to get hired. What else is there? We just saw closures. I would recommend. The iterators one's a bit boring, honestly. At least it reinforces closures. OOP is very good. Async's good. These Bower, we call them Build a Web App Bower. They're good. No, sorry, they're very good. They're very good. They're written by Phil. They just don't follow the hard pass model going under the hood. They're getting a taste with building with React. They're getting a taste with building with Node. It's fun. CSX online has video recordings of talks like this, and then a bunch of coding challenges around this material. And folk, even if you've enjoyed hard parts, the real value is when you do the coding challenges. That's where it's really at. Oh, two more things actually. One, if you want to pair program tonight with people, we don't really have a way of doing this. We need a dynamic shared code pad where if any of you want to code pair program tonight, you could put your names in. Let's just quickly do that. Let's quickly create a Google Doc, and you can put your emails in there. And if you want to go chat, I'll just put it. This is a good idea, actually. I like this. It was the brilliant. Who was it who came up with this last time? Oh, this great woman. Well, I can't remember her name is. Great. She's fantastic. She's in CS Prep right now. Oh, what's her name? Arthea? No. I can't remember her name. It begins with A. Okay, so JSHP closures Feb 27. I'm going to share this Google Doc, so anyone who wants to connect after this can put their email in and chat in here, basically. It's going to be editable by anybody. There you go. Here's the link if anybody wants to go and work together for a bit. Is this a West Coast IPA? I don't know. I like the East Coast IPAs too, for sure. One sweet, one sour, indeed. Wise words, Michael. Wise words, indeed. Stone Brewing, Green Flag. Oh, very nice. Yeah, very nice. Ballast Point. I know. Believe me, people. I'm not a connoisseur, but I've drunk all of these. Very, very my favorites. Okay, so the final thing to add, if you want to go to that doc and put your names or whatever in to chat with each other, I'm not going to be involved in that. But feel free. Oh, I just one other thing. There's this great person called Tracy. She is as it happens, the partner, the wife of Eric Kirsten, who is the guy who helps negotiate up the salaries. I can't deny that Codesmith's average salary is probably lifted up by about $7,000 because he negotiates with every graduate their salary up in a very positive way. He gives them the exact wording to get their salary up to the right point when they get an offer. So his wife actually also works with Codesmith. I mean, they both work here in their own right. I say his wife, the two of them work there together in their own right. And she is a career advisor for people who are trying to get into Codesmith or just trying to succeed in general. So if you do want to get her advice, put your phone number, DM me it directly in here, put your phone number in directly to me. The final thing I'm going to add is this. If you are trying to get into Codesmith, if you're not Sahara, hi Sahara. If you're not Sahara, no. If you are trying to get into Codesmith, fair enough, right? The bar you can see is fairly high. I mean, it is. I believe anyone can get into Codesmith. It just takes some people a year or two, and some people get in within 2 weeks. So you saw our friend here at the start, Ben. What's his name? Ben Hughley. What the fuck's his name? Ben Hawley. He got into Codesmith after starting to learn to code like 5 weeks earlier. 3 weeks earlier. It was ridiculous. But he got so good so fast. Okay, fine. He got into Google, Palantir, Facebook, Uber, and 2 Sigma. And I don't think any of his offers were below 200K. Should have said that. I don't know what his offers were. Remove that I said that. Who knows? All right. So if you're trying to get in, how do we do it? Well, it's through this thing called the Fast Track application. I believe I have a link to it. Hold on, people. Here it is. 7J65. 7J65. So if we go to, I never know how to do this. I think you go to Codesmith. By the way, people, if you haven't watched the performance on the Oscars by our dear Gaga, Stephanie, and Bradley Cooper, oh my God. As I'm watching it, I'm doing spontaneous applauses each time I watch it, singing it by myself. Oh, unbelievable. Right, so this is how you do it. You go to codesmith.io/apply/ whatever that code was, 7, what is it? And this takes you to a hidden application that doesn't, that guarantees you interview. It's like a coding challenge. It removes the essays. There it is. So there you go. It's got optional challenge code, fast track application, skip the essays and just show us your coding skills with special coding challenge. Guaranteed interview, a non-technical interview followed by a technical interview, and then the admissions decision. So it guarantees you. If you're not going for that, people, I strongly recommend you go for this. Well, this is our outcomes from the previous round. The average salary was lower, but very excited to take this now. 110, oh yeah. 115 New York, 105 LA. I don't know why. Must be higher in New York for a reason. If you don't want to try and get into the program yet, CS Prep is a good place. Here's my view. Codesmith is hard to get into for a reason. It means it works. But I do believe anyone can get into it because we have all these free workshops so that people can. I've never liked the fact that people go to these programs, get a junior developer job afterwards. Have you seen the percentage of people getting jobs out of my favorite programs? I was shocked. My belief is you can do that without paying $18,000 or $15,000. You go to Codesmith when you've got that level and you want to get that mid-senior level. That doesn't mean that so many people do, you have to do another programming bootcamp. About a quarter of Codesmith students have done another programming bootcamp. I think that's a shame. There is a scholarship for that, up to $4,500 if you've done another program to kind of compensate people for the roughness of having to do another program. But you don't have to. Just come to hard parts every single week. And even if you never apply to Codesmith, I don't mind. I just make sardonic, mean comments, which is regrettable. I will never do that again. Sahara, you're amazing. You're a wonderful person. And I'm super glad that you're achieving so much. I really, really love it. But if you do try and get in, it's all about attending these free workshops. And regardless, you're so welcome, all of you. Even if you've done another program, you're always welcome to all the free workshops because in the end, what is life but the pleasure of explaining things to others and empowering others? It is probably the only thing that is objectively a pleasure, besides running and music, besides exercise and music, an objectively healthy pleasure. There are other pleasures. Food is not that healthy. All the good stuff. Drugs, definitely not that healthy. Other pleasures, not that healthy. Teaching others, always healthy. All right, people, there we go. I'm not sure that was quite as inspiring a speech as I was hoping. I'll leave that one to fester. Folk, I hope you made connections in the Google Doc. I don't know if you did, but hopefully you did. If you want to pair programs, certainly do so in there. Get in touch with each other. And otherwise, folk, it's been a pleasure. I look forward to seeing many of you tomorrow in New York City at Codesmith headquarters in Tribeca. And then next Thursday, I'm in Los Angeles for 2 weeks, and I'll see you all in Venice Beach in LA next Thursday. I'm very excited. I don't know why I'm so eager to be back there right now. Really looking forward to it. See you tomorrow, Dwayne. See you tomorrow, YC. Looking forward to seeing you the first time in person. Shinyi, I hope you make it tomorrow in person. Oh, challenge code was, sorry again. Challenge code, people, was, what was it? What the hell was it? 7J65. 7J65. Codesmith.io/apply/7J65. And if you're intimidated by getting in, apply to CS Prep and go for a scholarship because there's lots of them for CS Prep. Especially if you're from a non-traditional background, meaning particularly people of color, non-binary, queer, like myself, women, those who are non-binary. There's lots of scholarships for CS Prep and for Codesmith. All right, folks, it's been a pleasure. It's been a real pleasure. I will see all of you. My friend is downstairs. Peace out, folks. Have a lovely evening, all of you, and see you all very, very soon. Thank you for your great contributions. Really good work, everyone.
Thank you. It was awesome.
Thank you. It was awesome. Thank you.
Bye, folks. Thanks, everyone.